Welcome to case study number 10 of the course on modeling activated sludge systems. This time I've decided to share with you the results of a very recent study that we have done in Croatia in the city of Poreč. This study is not only about wastewater treatment plant modeling, it is also about integrated system modeling where we include modeling of a sewage catchment, wastewater treatment plant and receiving waters. In this case, it is a beautiful coastal sea of Poreč area. This study is a part of the project Poreč. So there is a difference between project Poreč and study Poreč. Study Poreč is work that we have done. Project Poreč is the job that others have done. But these two activities are connected. So first I will say a few words about project Poreč. Poreč is located in Croatia, and the location is this red dot, which is part of area called Istria. It is very beautiful area, and most of the income to this area comes from tourism. The study area includes 4 different catchments which are all coastal. And we start from the left going to the right. The first catchment is called Lanterna. The second is called Poreč Sjever, which means Poreč North. The third one is Poreč Jug, which means Poreč South, and Vrsar. So far, before this project was introduced, the wastewater was only treated by some kind of primary treatment, and you can see the location of these existing wastewater treatment plants in red dots, and then just primary treated water was discharged into the sea by the long sea outfalls. You can also see these outfalls at this picture. The new project introduces construction of 4 new wastewater treatment plants, and location of these treatment plants is now different than it was before. The new location of these treatment plants is depicted by these green dots on this picture. Only in the case of Vrsar, treatment plant where it was before and where it is now is almost identical. The image under on this slide also depicts the beaches of this area. So these are all beaches which have a blue flag, which means the highest water quality for bathing. So the project Poreč was, and I still think it's the largest investment that Croatia put in a wastewater infrastructure of 67 million euros. It included 61 kilometers of new sewerage pipes, 23 kilometers of sewer system was reconstructed, 32 new pumping stations were built, and 50 pumping stations were reconstructed, and 4 new wastewater treatment plants were built. These are images of the treatment plants which are now operational. Poreč Jug, 48,000 person equivalent. Poreč Sjever, 37,000 person equivalent. Lanterna, 30,000 person equivalent. And Vrsar, 22,500 person equivalent. And you can also see in many of these treatment plants, in many of these 4 of these treatment plants, how close is population. So in this case, in Vrsar, these houses there are just a hotel resort. Now, let me come to our Poreč study Poreč as we call it. And scope of this work was actually sewerage systems. We have 4 catchments, wastewater treatment plants, 4 treatment plants, and the coastal sea in protection in the length of 23 kilometers. We developed a number of scenarios, and in this particular case, what is important, the difference between summer and winter conditions. In the summer conditions, we have a touristic season in Istria and in the rest of Croatia, so the population is increased by many times. In the winter conditions, we have less population, and it's mostly domestic population. And of course, we have a maximum and minimum situations in these 2 periods. So that brought us to basically 8 different scenarios that we envisaged. So these 8 scenarios were subject to modeling. So let me explain now all different modeling elements of this study. So we started first with the modeling of sewerage systems. As I already mentioned, we have 4 different catchments and 4 different areas to model, and what we modeled in this particular case were primary and secondary mains, and we did not model every single pipe in the system. So the catchment information is shown in this table. We have a total length of the pipes of 277 kilometers and 88 pumping stations and many manholes, 8,600 pipes, and the total area was around almost 3,000 hectares. We selected the 2 different scenarios for modeling. There are two modeling approaches, one for the present situation, that was at that time 2022, and the future situation set up as a design horizon of 2045. And when for each model we developed 4 scenarios for each model minimum and maximum load for winter and summer periods, as I already mentioned. So the model was developed by a consulting company who was also leading this project, and the winter and summer conditions were distincted. So the model was applied, and we tested the model, and we looked into simulated results with the measured results, and we only saw only few percentage difference in the results, which really showed very satisfactory results. That also happened in summer conditions. When you compare simulated results with measured results, you only see few percentage difference in the results. So we evaluated this exercise as very successful and satisfactory, so that we can continue using this information from a sewer system as a feed into wastewater models. We also looked into more detailed into winter conditions, but now for 2 different major scenarios: for the current situation in 2022 and evaluation of the situation in 2045. And we found out that there will be increase in the load to the system in winter conditions to, for example, maximum 25% when we talk about the minimum flow. And similar situation we also calculated for maximum flows, when in the future the difference in the flows between current situation and the future situation will be up to 25%. So this was also used to calculate the flow and the load for the design horizon. Then we have a situation in the summer, which is remember situation when we have lots of tourists there, and predictions were that the flows in 2045 will be up to, let's say, 20% different than what we have now. So based on this, we could also now create a relatively clear picture of the current load to the treatment plant and the future predicted loads in 2045. Based on the hydraulic model of the 4 sewerage catchments, we also now need to create more knowledge about quality of a sewage in these catchments. So therefore we applied quite detailed analysis of sewage, and we performed quite detailed sampling program. More about sampling, design of sampling programs, and how you evaluate the results is presented in chapter 3 of this online course. So here I will not cover this matter in depth. I will only talk about the results. So we decided to introduce 3 sampling campaigns. 2 of these campaigns were without wastewater treatment plants, and 1 was after the wastewater treatment plants were built. So the first one was done in January 2019. We had the sampling campaign which covered 7 days in location of seawater discharges, and in total 336 samples were executed. In July 2019 was a second campaign, 7 days at location of seawater discharges, and you can realize that January is a winter in Croatia and July is a summer. So therefore we targeted these 2 seasons. And once the wastewater treatment plants were built, in January 2022, we executed a 3rd campaign of 4 days at location of wastewater treatment plants, and we only looked into influent and effluent of the plants, and in total we covered 96 samples. We took into account 15 different parameters and executed in total more than 10,000 analyses and more than 400 analyses of a seawater quality that I will explain a little bit later. So to start with the winter and the summer campaigns, sampling campaigns in 2019 at 4 locations at the present discharges of the wastewater into the sea via seawater outfalls, we installed automatic samplers and collected samples during the 7 days, 24 hours per day in composite samples. In the winter 2022, we did this exercise at the treatment plants, and all 4 wastewater treatment plants have their own sampling machines as a part of the project. These machines were installed at location of influent and effluent of each wastewater treatment plant. We collected, as I said, many samples. More than 10,000 analyses were done, and almost 1,000 samples. And these were analyzed at 3 different locations: at the Institute of Agriculture and Tourism in Poreč in winter conditions. In the summer, we did all these analyses at the Faculty of University of Zagreb. And in the winter, there was also, in winter 2022, the laboratory at one of the treatment plants was finished, and it was serving as a central laboratory, so we did our analysis at this lab. Here are the parameters that we checked: COD, COD filtered, BOD, BOD 5 filtered, so these are carbon-related analyses, total suspended solids in organic and organic, so solid analysis, and then different fractions of nitrogen, total nitrogen, ammonia, nitrate and nitrite, total phosphorus, phosphate, so related to phosphorus, and pH and electroconductivity. Electroconductivity we did just to check if there is infiltration of seawater into sewer system and wastewater treatment plants. For this presentation, I can only show you some representative examples of analytical work that we have done. The full reports are available, so if you are really interested in details, we can supply you on demand with details of these studies. So this slide depicts the results related to COD taken at the Poreč Sjever wastewater treatment plant in the summer 2019. On the left-hand side, you can see the results and the daily variations in the period of 7 days related to COD and COD filtered. The COD is in blue and COD filtered is in orange, red dots. And from this data, we could collect also daily average data. I think we here used 12 samples per day of 2-hour composite samples of wastewater taken by automatic samplers. And you can see also that the COD values is around 1,000 milligram per liter, saying actually that this is quite concentrated sewage, and it's in summer conditions. So we have here a very little contribution from rain, and also the wastewater collection system is designed as mostly a separate sewage system, so separately treating and taking sanitary sewage from a rainwater system. Information about nitrogen we have at all 4 wastewater treatment plants, but here I just show from Poreč Jug in the summer 2019 the variation of total nitrogen and ammonia nitrogen, and you can see quite some daily variations, and at the daily average values show the concentrations of total nitrogen of about 100, and ammonia of about, on average, about between 60 and 80, which means that again this shows a little bit more concentrated sewage that we are used in combined sewer systems. Regarding phosphorus, we took data from Vrsar treatment plant in the summer 2019, and you can see that the daily variations in phosphorus ranging from 2 to 10 or a little bit more milligram per liter, and daily average is around, let's say, 8.5, which are normal, let's say, concentrations for wastewater without industrial discharges. And we have suspended solids from the fourth treatment plant, Lanterna, in the summer of the same year, where you have a daily variations, again, and the daily average of about, let's say, between 400 and 500 milligram per liter, which is again in the range of normal sewage characteristics. So what was interesting in this particular stage of this project, to compare the measured data in winter and summer 2019 and design values for 4 wastewater treatment plants, because we also aimed to verify the starting point of the engineering design and to see if the treatment plants are really capable of treating the current load. And it was the case, of course, that was also demonstrated by this analysis. We can see that for each of the 4 wastewater treatment plants, the installed designed capacity is higher than the current capacity, and there is in all 4 cases a difference between the current load and the future designed load, and that is also by design. And the differences were not huge, which also shows that the designer took care of the efficient design so that the treatment plant were not really over-designed without really knowing what will happen in the future. So also, when you compare with our modeling results from the sewage modeling, we also found out that the maximum difference will be in the next 20 to 25 years, about 25% increase in hydraulic load. So these results about the flow were really satisfactory. When we talk about BOD, situation is similar. The carbon removal will definitely be fine, and you will see also later that the plant performed satisfactory, and that was also the case in suspended solids. And when you analyze these results, you will also realize that the design was really efficient in a way of not providing unnecessarily too large space for additional load. Now, having the, and you will see it later, that the core of this system is in all 4 cases is membrane bioreactor system. So with membrane bioreactor system, you can increase the amount of biomass in the system. So in case that you need to create some additional capacity, you can really play with the biomass content in the reactors, and you can push your system even further. So that was another reason that this design was really efficient, because in case that you need additional capacity, you can manage it within existing volumes. What is other important fact is that the third sampling procedure were done in January 2022, when the treatment plants were operational, but they were only in a startup phase. And it is also the fact that not all wastewater treatment plants started up in the same time. So some were already 3-4 months under the startup conditions, and some were just started. So when I present you now with these results, please be aware that these are not results of the plants which were as such taken by the municipality as the final product. So this was still work in progress. But however, even as a work in progress, all 4 wastewater treatment plants show quite incredible efficiency. So only the last treatment plant, which was just started, had some issues with the COD and BOD, which is a carbon removal, and with the nitrogen removal, because the system was not yet fully operational. But all others, even at the very beginning of startup phase, showed really high level of carbon removal, suspended solids removal in all 4 cases. This is expected because of the application of membrane bioreactors for solid-liquid separation, because normally they should work from the beginning straight away. Total phosphorus was also removed sufficiently in all treatment plants, carbon in 3 out of 4, and the nitrogen in 2 out of 4. So these are excellent results for this stage of development. That is important to mention. So when we make conclusions on this part of the study, we found out that there are typical concentrations and daily variations of all measured parameters. COD load and flow is in line with the design. Winter and summer load is very interesting. In Lanterna, 1 to 15, which means that in the summer we have a 15 times more load than in winter. In Poreč Sjever, 1 to 2, and that's also expected because Poreč Sjever is a city with mostly autochthonic people and very little additional beds for tourism, while in Poreč South is not the case. There are big hotels, the ratio is there 1 to 10, and Vrsar 1 to 5. So this is also very much interesting to see 4 wastewater treatment plant at a very limited location of 23 kilometers with the differences between 1 to 2 to 1 to 15. Wastewater treatment plants already at the startup satisfy most of discharge standards, and we also found from electroconductivity measurements that there is a limited seawater infiltration in the sewer system, which is a good news, which means that there is no much infiltration in the sewer system from the groundwater and seawater. And let's move now to a seawater sampling. So the seawater sampling was important and has been done also in the 3 campaigns in the same time as we did sewerage campaigns and wastewater treatment sampling campaigns. It was done at the same locations of the discharge, but now the seawater sampling was done at the point where the offshore discharges were located at a distance of between 500 to 1,500 meters from the shore. And we also did influent and effluent sampling in 2022 at the wastewater treatment plants, plus number of seawater analyses. For that, we needed a boat, so we used the boat of our partner of the research center from Rovinj, and we had very equipped staff and with the skills and equipment to perform this analysis. So what is interesting here is a selection of the sampling points, and you can see on this image on the right hand side that we have 4 areas of sampling. The point A in each of these 4 cases is the place where is the mouth of the offshore discharge. So that's a place where wastewater is discharged into the sea. Point D and point B are the points which are in line with the currents that are occurring in this area. And point C is very interesting and very important because that's a point which is located at 300 meters from the shore, which is by the law prescribed shoreline where the seawater bathing quality should be ensured. And in each case, we have 2 sampling points, B1, B2, D1, D2, and C1 and C2. And that also happened in all 4 locations. This is now in large image of that so that you can understand the strategy behind the sampling. For that, we really used state-of-the-art equipment, samplers which can take seawater samplers at different depths, and we really were looking in this particular case only for indicators of a fecal pollution. The Escherichia coli and the coliforms and intestinal enterococci. We performed about 410 samples and we obtained very nice analysis. So in terms of results, the results showed really normal concentrations in a sewage ranging from 10 on the power 7 to 10 power 8 of coliforms, and so there was no surprises here. When we looked into influent and effluent after wastewater treatment plant startup, we already got some very good results here. So if you look here on the left-hand side in the table, you have names of the treatment plants, and you have 3 different analyses, influent and effluent. And you can see, for example, if you look into effluent numbers, Lanterna has 0, 0, and 0, which means that at this treatment plant already the system works very well, and this is mostly due to very high efficiencies of the membranes, which really, in this case, stop majority, if not all, fecal pollution. The similar situations were in the other treatment plants, and in those where you still see some fecal pollution in the effluent, that was mostly because of the fact that in all wastewater treatment plants here, so all 4 wastewater treatment plants have a reservoir of clean water. So the effluent is collected into reservoir. Why? Because this system here is designed in a way that it's really working on circular economy and reuse of resources. So in this case, the idea is to reuse the clean effluent, and that was one of the main reasons that an MBR system is employed here, because of the reuse of water, and especially in the summer time, where there is a lack of water supply into system in the city in general. So why we have now some fecal pollution in this reservoir is because the treatment plant just started and some of them never discharged the effluent. So there was some regrowth in the reservoirs because the attention during the startup was not really on the reservoirs but on the main heart of the system. So when we took this analysis, we asked the operators for the first time to discharge effluent into the sea, and there were also some water which was in the pipes already from long time of before. So we have to wait until this wastewater is discharged, until our wastewater, our real effluent, comes from the reservoirs, and therefore we have some fecal pollution there. But in a normal situation, when everything is fully operational, we would expect similar excellent results in all 4 treatment plants. This is maybe on the first look a complicated slide, but this complicated slide is not so if you try to understand what is in it. We have 3 campaigns, winter 2019, summer 2019, and winter 2022. And in these boxes, we have results of our study, of our sampling. And what is important, for example, that you look in boxes signed with the C, because that's the 300 line where there should be no fecal pollution coming to the beaches. And you can also see 4 different wastewater treatment plants in these pictures horizontally. And you can see that even without wastewater treatment plants, so in the winter and the summer 2019, situation at many locations of sampling was already fine, which is thanks to currents and thanks to environmental conditions in the sea. But the most important one is that in winter 2022, when the treatment plants were operational, again, not all were fully 100% efficient as designed. We see that at many places we have actually empty boxes, which means no fecal pollution noticed. And where we have, it's just because of the reasons that I just explained. So this shows that what is the impact of really having a wastewater treatment plant, and how also the sea ecosystem can be protected, and also the users of the bathing water, which are tourists. On top of that, we did some also scientific research. So we have modeled seawater quality, and I will show you later on a very detailed story about that part of modeling. We also did day and night decay experiments of bacteriological indicators of biological pollution, and we performed a decay test during the night and during the day, and we got decay rates that we later used in a model to substitute the default values in the model so that our predictions are even more accurate. So in these conclusions, I already mentioned most of these conclusions, that we observed the usual concentrations of fecal indicators in all 4 sewer systems, that the some treatment plants are currently more efficient than the others, but this is because they all started up with a span of 3 or 4 months difference. The immediate improvement of microbiological situation in the sea was observed. And what was also important, and I mention now for the first time, is that we also observed the thermal stratification, and it became a main factor for spatial distribution of fecal pollution in the seawater. And I will come back to that a little bit later. And all samples from locations C, which is 300 meters from the coast, are characterized as an excellent bathing water quality according to the local standards. And samples of unsatisfactory quality origin from the winter 2019 are only at the surface of the and in the summer on the deep sea. But these samples were obtained without wastewater treatment plant in place. At this stage of the study, we have successfully completed the modeling of the 4 catchment of sewerage. We completed quite extensive analysis of sewage quality and of seawater quality. And now we have enough information to enter into a modeling of 4 wastewater treatment plants. What is common for these 4 wastewater treatment plants? That they applied identical technology. Only the capacities are different. And of course, influent quality is different from treatment plant to treatment plant. But the treatment process is the same. For each wastewater treatment plant, we applied model separately. We based our modeling on a static model, and we started with the information from the design documentation. So we modeled the treatment plants, all 4 of them, using the information from the design documents. And then we calibrated that model based on the winter and summer 2019 data. Remember, these periods are without wastewater treatment plant in operation. And then we used the model to develop scenarios to predict what will happen in 2045. Such model we validated based on the winter 2022 data campaign. We, in this study, produced 4 really detailed design modeling reports, from which I only take a glimpse of the results, that you can just get some idea of type of information that we can obtain from modeling. From modeling, we use the BioWin software with activated sludge models. Here we show, for example, average wastewater flow per day, minimum and maximum measured based on the information from households, and this is also based on the information that we got from the modeling for sewerage catchments. Then we have done all kinds of predictions of the flows coming to the treatment plant, which are really needed for a model, and you can obtain such kind of 3D graphs. At this stage, I'm really not going into details of all these numbers because that's not necessary. This presentation is to show you the methodology and the results that we got in this study, so the overall results, not the detailed results. We applied, as I said, the BioWin model and BioWin simulator, and this is an example of one of the 4 wastewater treatment plants, and as I said, the other schemes are very similar to this one. And then, based on the modeling exercise, using our static model and then a model which is calibrated on sampling campaigns results from winter and summer 2019, we got to this stage where we could model situation in 2045 And then we extended validation of the model using the data from the campaign when the treatment plans were in place. And these are just some images from many possibilities that the software can create, and the way how you present the results regarding the effluent, regarding the effluent quality, regarding the flows, but also any units in a treatment plant you can isolate and show in and out and the efficiencies of each particular unit. So there are many conclusions from these detailed modeling studies, where we were quite happy with the static model that we developed based on documentation. That model was really using detailed design of the consultant and measured average influent data from sampling campaigns. The model is completely based on the default BioWin parameter settings and information from detailed design. So in this particular case, we did not change any of the default parameters of the model. Static simulation also showed that the wastewater treatment plant performed according to the effluent and design requirements for both winter and summer conditions. And that was very important conclusion of this first part of the modeling study. Then here I have a bit more detailed analysis of each particular aspects of the modeling study and related conclusions. But in general, just to summarize it, we were really happy with the results. The calibration was done really successfully, and we were very comfortable with the models that describe all 4 wastewater treatment plants very accurately. The scenario 2045 was based on the calibrated model and showed that, what is also important, that all 4 wastewater treatment plants will be able to deal with the incoming pollution in that year of our design horizon. So treatment plants are expected to operate also efficiently in coming years when the flow and load will increase. And the validation based on the winter 2022 data was very important, because the model was tested successfully on independent data set and reproduced all data without significant adjustment. And it also shows that the model is reliable and validated for use for operation and scenario evaluation. So, which means that the model can be applied to all presented results under which previous wastewater treatment plant modeling reports published in this series, which have used the validated model. So basically, we are very satisfied with the process and the results that we obtained in all steps of wastewater treatment plant modeling. Then, by successfully completing the second big modeling part of the study, we moved into the last part, which is the modeling of seawater. As I said before, we really looked into the seawater quality modeling of dispersion of sewage effluent, which are, in this case, the most interesting part are fecal pollution along the Istrian coast, and that was a stretch of 23 kilometers. We assessed the risk of Escherichia coli and intestinal enterococci pollution of the beaches, and the added value of treatment plants to reduce the risk. The first 2 parts of this slide you have seen already at the beginning of my presentation. The third part is added, which is basically the area that we covered by this study and the area that we covered by our investigation. So for the seawater modeling, bathymetric data were very important, and we didn't have really a good bathymetric data to start with this study. So we have to obtain lots of results ourselves. We have included a specialized company from the Netherlands to perform bathymetric data and some additional measurements that they did with their own equipment, with the ski boats, which were equipped with the various type of sensors and equipment, obtaining the data according to the prescribed roster, so the prescribed resolution that we defined together with the local authorities, and we instructed our partners here to perform a collection of data along the coast in 2 dimensions, and you can see also some results already on these small pictures on the slide. And we also use the boats that we already mentioned from the local Institute for Oceanographic Research, which were our partners in the project, and they were also collecting other data from this area. So the modeling part of the seawater quality was done by our partner from Belgium, and this part of presentation is in fact their work, and I will not go to all of details of it, but if you are interested, you can contact us and we can provide you with more details. So here we just described what were the phases that we applied in the seawater modeling. We needed to do quite some work here, and this study included collection of lots of data and analysis of this data. We were collecting data on tidal variations, on the currents, on the wind events, and also, and that is very important here, occurrence of stratification in the water column between winter and summer conditions, because water depth in this area is not really high. The water depth at the area of seawater discharges, of effluent discharges in offshore discharges in the sea is about 25 to 35 meter depth. We collected lots of data about bathymetric and current conditions, and we collected them and sorted them in a way that can be used by our modelers. We used the modeling approach, which is a 3D process, and we looked into fume formation from the discharge of from the offshore pipes. In the seawater modeling study, we used 3 different models. The first one was a far-field model of Adriatic Sea. The second one was a mid-field model around the Istrian Peninsula. And the third one is a near-field model, which was designed around the discharge of effluent into the sea. The model has been calibrated. The hydrodynamics was evaluated for 2 seasons, winter season in October 2018 and the summer season in July 2008. These data we didn't have originally from our study. These data were collected from other studies in the region. We also obtained information about the currents to be checked in a mid-field model, but also we have to reanalyze them using the survey data. We took into account wind conditions, current patterns, and we also compared different current fields, which showed really good comparison. So with this data, we could continue with our modeling exercise. Then we also obtained information about the currents, and we calibrated the currents so that we could really get a good prediction of the currents along the Istrian coast, and specifically in this area of the length of 23 kilometers. Then we needed more data about water quality. These data were obtained from the sampling procedures that I have already explained. The first 2 parts of the graphs I already described, and also the data from the decay experiments we used to model decay of fecal pollution. Then, based on this information, we calibrated model on the water quality. We assessed 2 different situations where we have stratified conditions and we don't have stratified conditions, and this situation occur in the summer and the winter. And you can see here very nicely the situation in the summer where the water column is stratified, and on the bottom part of the slide you can see this yellow greenish area, and that is the area of the pollution. And you can see that the fecal coliforms are not really coming to the surface. They are somewhere suppressed by the stratification, where we have a warmer part of the water on top and the colder part of water underneath. And this is a quite sharp stratification, which actually help additionally in this case. And that was one of the reasons that even without wastewater treatment plants, in summer we could not observe much bacteriological pollution on the beaches at the surface, because pollution was kept under the surface at a level of up to 3 to 5 meters. In the winter conditions, system is stratified, water column is stratified, and you can see that pollution comes to the surface. However, again, without wastewater treatment plant, that was not a big problem, because there is no bathing activities happening in winter, so nobody could be affected even if bacteriological pollution comes to the surface. And later on you will see that when the treatment plants are in operation, there is absolutely no risk of bacteriological pollution at the beaches. Then we applied scenario modeling, as I explained before. Situation with and without wastewater treatment plants were examined, and the model showed very interesting results. On the left-hand side, on this graph, on this image, you can see a situation at 4 locations where there is some pollution observed without treatment in place. And on the right-hand side, you can see a situation with wastewater treatment in place, and you can see no sign of pollution. And this is really the evidence of the impact of having a wastewater treatment in opposite to situation where we don't have it. Then we applied validation of the wastewater treatment and seawater models, and we looked into all kind of parameters and sensitivity analysis, and we came up with the main messages that seawater quality modeling is really important, because it brings to understanding of the local conditions, about the local currents, discharge characteristics and conditions, decay rate in a local environment, which are really low.